Let's start now lecture number 22. We are going to how to solve systems of linear differential equations using Laplace transform section 7.6 from your textbook. Here we are going to apply the probabilities of Laplace transform to solve system of differential equations. By the way, it's very similar to solving one single differential equation. But now we have to solve coupled of system differential equations. The objective here, and here in this slide, I attached some rules. I added some rules of Laplace transform. This is my cheat sheet. Notice here at the beginning, you have the definition of Laplace transform using the integration formula here. Also here, the Laplace transform of a product between two functions, one of them is the exponential. We call it shifting on s-axis, and its inverse here. Also here, the product between two functions, one of them is the unit step function. We call it shifting on t-axis, and its inverse is given here. Then we move to Laplace transform a product between two functions. One of them is polynomial, and it's given to be the derivative with respect to s of the Laplace transform. And we studied also the Laplace transform or Laplace inverse of a product between two functions to be their convolution. And this theorem or this identity comes from this rule, which is the Laplace of the convolution. This is my convolution between two functions is given to be Laplace of the first times the Laplace of the second. And from this rule, we can find the Laplace transform of any integral. And from this one, we can find Laplace inverse of the function divided by s. Don't forget the rule of Laplace transform of the unit step function. This one also is very important. I need all those rules for the final exam, okay? Now let us, I'm not going to explain the phenomena which need this system of differential equations, because as we agreed yesterday, I'm not going to include the phenomena problem in the final exam. But what I need you to know, how to solve system of differential equations without studying the phenomena. So I'm going to give you the system and you will solve it without studying the phenomena. Don't forget that we studied in lecture number 15, if I have one single spring and one mass, I can formulate this phenomena or this motion using Newton's second law as a second order differential equation. Now, if I have two springs, this one and this one, and two masses, this one and this one, I can model this phenomena using Newton's second law as two differential equations, like this. I'm not going to ask you to write those two differential equations. What I need, that if you have this system of differential equations, notice now you have two unknowns, x1 and x2, x1 and x2, x2 and x1. You have two unknowns. And differential equations, system of differential equation, we call this system coupled. Why do I call it coupled? Because in the first equation you have x1, 1, and x2, and also in second equation 2, 1, 2. So your two unknowns are in both of your equations. Now, how to solve this system using Laplace transform? So for my students in this semester, they know how to solve system of coupled of differential equations using Laplace transform. Depending on the following steps, you need to take the Laplace transform for both sides of your equations. Then you need to eliminate the x1 and x2 capital, then take inverse as usual. Let me explain in details how to solve the following system using Laplace transform. So I have here solve the following system of differential equations. I'm not going to ask you to use Laplace in the exam, but you have to know that I need to use Laplace transform. And let me tell you that in the exam, 100% you will find one question similar to this system, and you need to use Laplace transform to find its solution, at least 10 marks. Now let me do that here in the black slide. Here is the solution. as we agreed, if I have uh, two differential equations and I need to find their solution using Laplace transform, I need to apply Laplace for both of my equations. So now I'm going to apply Laplace for both of them. Don't forget that your unknowns now are x capital and y capital, and the derivative with respect to t. No problem for me. Now I'm going to find Laplace for the first equation. So I have Laplace of x dot, which is the first derivative, plus Laplace of y equal Laplace of cosine t. Now, Laplace of the first derivative is given to be sx capital minus x of 0. It's a rule. Plus Laplace of y small is given to be y capital equal Laplace of cosine. I remember it is s over s squared plus 1. Any question here? Did you get the idea? Now, what I'm going to do, I'm going to write the negative x0, it's negative half. Move it to the left-hand side, so it will be half. That will give me sx capital plus y capital equal s over s squared plus 1 plus half. You can here find the common denominator. No need. No, not going. You can leave it like this. This is the first equation which contain two unknowns, x capital and y capital. This equation, it is algebraic. It is an algebraic equation, not similar to the given equations differential. No, the new one, which has number 1, it is algebraic equation. Now let me apply.
Doctor,
Yes, David.
where did the half come from?
The initial condition, x0, this is x0, is given here.
Oh,
This x0 is given here. It's half. I move it to the right-hand side, so it's a plus half.
Doctor,
Yes, Mahmoud.
well, isn't it s squared minus 1?
Cosine, it is s squared minus 1. Yes, excellent. It is x squared minus 1. I'm sorry. The cosine, it is x squared minus 1, not a plus 1. Great, Mahmoud. It is s squared minus 1 because the cosine plus and cosine minus. Great. Now, second step is to take Laplace transform for your second equation. So I have Laplace transform of y dot plus Laplace transform of x equal Laplace transform of shine. So that will give me the Laplace transform of y prime. It is sy capital minus y at 0 plus Laplace transform of x small. It is x capital equal Laplace transform of the shine. It is 1 over s squared minus 1. Now let me write this equation as the following. I'm going to write x first plus sy equal, I'm going to move the negative y0 to be half. So it is 1 over s squared minus 1 plus half. This is my second equation with the unknowns x capital and y capital. This, it is y, not x. Okay, this is y. Now you have two algebraic equations with two unknowns, x capital, y capital. How to find those two unknowns? Can anyone suggest a method to solve this system of algebraic equation? How to find x capital and y capital?
Can we multiply the second equation by negative s and
Add them together.
Yes.
Yes, I can do that. So the first method, Islam suggests, Professor, I can multiply the second equation, number 2, by negative s and add those two equations together. So at that time, you will cancel out the x. You are right. This is the first method. And actually, to be honest, I'm going to use this method because Islam, who first one suggests the method. Now, I need other methods. Any idea how to solve this system? maybe you will eliminate y from the first equation and plug in the second equation. You can do that. And also for me, I can use grammar rule to find W1 and W2. If you remember, grammar rule, Wronskian determinant. I can do that. Now I'm going to solve using the method which Islam suggests me to do. So I'm going to use the blue now, and he said, Professor, multiply second equation by negative s. So it will be negative sx, negative s squared y, s squared y, equal negative s over s squared minus 1, negative s over 2. S over 2. Now I'm going to add those two equations. Let me call this 2 prime. Okay, so here s negative s times 2 give me the following. Now Islam suggests, Professor, add 1 plus 2 prime. Let me check what I have now. If I add those two equations, sx minus sx, it's 0. Y minus y squared s, I can take y as a common factor. So I have 1 minus s squared equal s divided s squared minus 1 equal negative, plus negative s over s, you will cancel them out. Half minus half is, so I can take half as a common factor maybe. Half. So I have 1 minus s. Am I right here? This one, it is y. Any question what I did here? Is it clear? Now I'm going to divide by the coefficients of y. So I have y capital equal half times 1 minus s divided 1 minus s squared. If you can simplify, please do that. If you can't, take the inverse, please. Can we simplify this one? Yes, I think we can. This, it is 1 over s, and the half here, don't forget. And here 1 minus s and 1 plus s. I can cancel this with this. So I have my y capital to be a half 1 over 1 plus s. Or s plus 1, don't worry. Now give me the y small by taking inverse Laplace. So you will get y of t equal half Laplace inverse of 1 over s plus 1 or 1 plus s, no problem, which is half e to the negative t. Am I right here? This is your yt. You found the first unknown. Great. How to find the second unknown? Can anyone help? Can anyone help? How to find the second unknown?
Can we plug in the second equation in question, لا dy by dt equals
Yes. So
plus
look, David said, Professor, after finding y small t, plug in here in the second equation. So you will get x here. I'm not sure if you can see what I meant here. So I'm speaking about this. So David said, plug in here, Professor. After finding this y, take it to plug in here, and you will find x easily. Great. Other method which is more difficult than this, and by the way, sometimes you can't use this substitution as David suggests. You can't. In the coming example, I will see you that you can do that. Now it's very easy for you to do that. Or after finding y capital, plug in here. So you will get x capital and take inverse. That will be solve the problem. Now for me, I'm going to do as David said. In this differential equation, I'm going to take just 1 minute to use the white now, or to use the blue. So take this equation here, and plug in. The derivative, it is half e to the negative t, and you need half plus x equal shine t. That will give me negative. I'm going to move this. So x equal half e to the negative t plus the shine. I remember the shine. It is e to the t negative e to the negative t divided 2. Now this, it is similar to this with different sign. So x equal only half e to the t. I found the x and y. It's very easy question. What do you think? Let me go to the second problem now, which is more difficult than this. So here, also I need, but please write your names. I need you to write your names. Don't forget from this lecture, at least 10 marks for your final exam.
يا دكتور هو is the final comprehensive ما ينفعش
The final, as I told you, the final must be comprehensive. Why? Because I can cancel out some lectures as I did yesterday. I send you on WhatsApp some lectures that isn't included in the exam or aren't included in your exam.
Yes.
Yeah, but it must be. By the way, for the Laplace transform, you need all of them. I can't cancel out any one of the lecture of Laplace transform. Okay, Omar?
Yes, Professor. Thanks.
Now I'm going to solve this system. We agreed that if you need to solve any system using Laplace transform, you need to apply Laplace transform for all of your terms in all your equations. So now let me start solving here. Here's the solution. I'm going to apply Laplace transform for the first equation. So I have Laplace of x dot equal 4 Laplace of x here minus 2 Laplace of y plus 2 Laplace of the unit step function t minus 1. Now Laplace of the first derivative here is given to be s x capital minus x of 0. Now I have x0 to be 0 equal 4x capital minus 2y capital plus 2. What about of Laplace of the unit step t minus 1? I think we have a rule in the first slide. Do you remember? The Laplace of the unit step. Can I go back? So let me go back here and check the rule, please. Where is the Laplace transform of the unit step? Is given in this black slide. This is the yellow one here, the yellow one here. E to the negative as divided s. I'm going back. It is here. So e to the negative, my a is 1, so negative s all divided s. Now I'm going to collect all x and all y in the left-hand side. And x0, this one is 0, so cancel it out. It's 0. Now I'm going to move 4x here and take x common factor. So you have s minus 4. Okay. And move 2y, so it will be plus 2y equal 2e to the negative s divided s. This is my first equation. Now, to write the second equation, I'm going to use the yellow, maybe that would help. So second step is to take Laplace for your second equation. So I have Laplace of y dot, the derivative, equal 3 Laplace of x minus Laplace of y plus Laplace of the unit step function, which is t minus 1. That will give me now, let me check what I have now. I have the following. Notice it is s y capital minus y small of 0 equal 3x capital minus y capital plus e to the negative s divided s. I'm going to move the y and x. First of all, y of 0, it's half. So I'm going to move the half here. So it will be e to the negative s divided s plus half. I'm going to move a 3x, so it will be negative 3x. Move also negative y to be plus y. So I have y common factor here, a plus. Inside the bracket, I have 1 plus s or s plus 1. This is my second equation. I have two equations with two unknowns, x capital and y capital. How to solve them? Can anyone suggest an idea to solve those two systems, two equations simultaneously? For me, actually, I'm going to use the grammar rule. How to use the grammar rule? I need to find the W. What do I mean by W? The coefficients of X in the first equation and coefficient of Y in the first equation. This is my first row. So it is S minus 4 and 2. Here, I have the coefficients of X first and the coefficients of Y from the second equation. Don't forget that X below X, Y below Y. Now to find this determinant, I remember this by this. So it is S minus 4 times S plus 1 minus this by that. So it is a plus 6 equal, let me multiply like this. So it is S squared plus S minus 4S minus 4 plus 6, which is given to be S squared minus 3S plus 2. And this can be factorized if you need. It is S minus 2 and S minus 1. This is my W. Then I remember a grammar rule need me to find W1. How to find W1? It's very easy for me. Replace your left hand side, replace the first column here by your right hand side. Where is your right hand side? Those here, this and this. So I'm going to write them 2e to the negative s divided s, and here also I have e to the negative s divided s plus half, and leave this 2 and s plus 1 equal this by this. So it is s plus 1 times 2e to the negative s over s minus 2 times those, which is e to the negative s divided s plus half. Let me distribute now the brackets. So it is here, I'm going to cancel s with s, so I have only 2e to the negative s. Here plus 2e to the negative s divided s minus, now the time for 2, negative 2e to the negative s divided s minus 1. This similar to this cancels them out, so you have only 2e to the negative s minus 1. This is my W1. Do you remember after finding W1, what should I do? Or what can I do?
Get X.
Find X. How to find X?
It's going to be W1 over W.
Great. So from this, I can say my X capital, the first unknown here in my system 1 and 2, it is W1 over W, which is given 2e to the negative s minus 1 divided by my W, which is s minus 2, s minus 1. So now I found my X capital. Take inverse, please. Take inverse, so Laplace inverse. So here you have Laplace inverse of X capital equal Laplace inverse of this fraction, which is 2e to the negative s minus 1 divided by s minus 2, s minus 1. I know that Laplace inverse of this, it's my first unknown x small of t. My first unknown x small of t. This is my x of t. How to find inverse of this fraction? Let me go to a new slide and try to find its Laplace inverse. So now I need you to find the inverse Laplace of the following fraction. Laplace inverse, so my x of t equal, let me write it in details here. It's given to be Laplace inverse of 2e to the negative s minus 1 all divided by s minus 2, s minus 1. Who can help now to find the inverse of this fraction? What do you think?
Can we split them first to inverses?
Great. So it is Laplace inverse of the first fraction, which is 2e to the negative s divided s minus 2, s minus 1. Excellent. And the second one, it is Laplace inverse, or not minus, don't worry. Laplace inverse of 1 divided by s minus 2, s minus 1, all of them. Let me first find the second one of them. So here I'm going to find Laplace inverse of 1 over s minus 2 and s minus 1, okay? Then I'm going to find Laplace inverse of e to, don't worry about number 2, don't worry about number 2, so e to the negative s divided by s minus 2, s minus 1. Both of them, I'm going to find them now. Here, who can help to find the inverse of the first fraction, please?
Partial fraction.
Partial fraction, great. Maybe you will do this partial fraction in 2 minutes, you are right. Now, maybe I'm going to use another method. Now, I need you to understand or to practice how to use the properties of Laplace transform. In your exam, you are free, and I think using partial fraction is better for this problem because it's very easy. But I'm going to use some properties of Laplace transform, okay, to let you practice how to use them. For me, I'm going to write this one as the following: Laplace inverse of 1 over s minus 2 times 1 over s minus 1. S minus 1. So for me, I can consider this is my F capital and this is my G capital. Do you remember the rule? Let me write the rule here. Do you remember Laplace inverse of F capital times G capital is given to be what? And if you want, I can go back to first slide, to my cheat sheet.
واف سمول اللي هي علامة الاكس دي في جي سمول.
Convolution G. Yes, convolution G. Yes, you are right. It's a star G. Now my question, what is F small? Or what do you mean by F small?
Laplace inverse of F capital.
Great, excellent. Laplace inverse of F capital. And the G small, the same. Now, can anyone of you give me the F small for this and the G small for this?
E power 2t.
2t, great. And what about of this?
E power t.
E to the power t, great. So the rule said you need the convolution of those, e to the 2t, convolution e to the t. Let me go back to the yellow and find the answer. The convolution, I remember from my cheat sheet, is given to be integral from 0 to t. The first function e to the 2 tau times the second function after shifting it t minus tau d tau equal. So I'm going to find the answer of this integration. So I can write integral from 0 to t e to the 2 tau times e to the t times e to the negative tau d tau. Am I right here? E to the t is a constant. Take it out, please. So equal. I'm going to continue writing here. Maybe I need to erase this. Give me 1 minute, please. I'm sorry. I'm going to rewrite it again, but I need the space here. So here, sorry. So equal. Let us continue here. Equal e to the t outside of the integral from 0 to t. Now 2 tau minus 1 tau, so you have only e to the tau, d tau. This integration is very easy for me, so it is e to the t times e to the tau from 0 to t, which is given to be e to the t bracket, e to the t minus 1, okay? Or you can write e to the 2t minus e to the t. So this answer is the Laplace of this fraction. Now let me find the Laplace inverse of the second fraction, which is Laplace inverse of not 1, it is e to the negative s divided by s minus 2 s minus 1. How to find the inverse Laplace of this? If you have exponential, do we have any rule with inverse and e to the negative s? Let me go back to my slide of the rules.
Shifting.
The shifting theorem, you are right. Let me show the students the rule now. Please, if you don't have your cheat sheet, you can't solve the problems. Look here. Where is e to the negative s? It is this one here. It is this one here. E to the negative s times f of s. You need to determine your f. So I need e to the negative s and f capital. So let me go back here. So for me, I can write this one in details for the students who can't deal with the probabilities easily. So I can write this one, s minus 2. I didn't do anything now. Only I need to explain that this one is my f. This one is my f capital. Okay. And here the a is 1. Now, as we agreed, the rule said you need to write, let me write the rule. I'm sorry, I'm going to write it in red. It is f of t minus a times u of t minus a. This is the rule. And the a I know, I don't know f small. This is f capital. Can anyone help to find f small? Where is your f small?
We
اللي
got
هي
The
t
inverse.
t
bar.
bar 2t minus t
Yes,
bar.
this is one. It is this one here. This is my f. This is my f. Okay, this is my f. So now I'm going to plug in my rule. So the answer is given to be. The answer is given to be f of t minus a. So it is e to the 2t minus 1 because my a is 1 minus e to the t minus 1. All of them I'm going to multiply by ut minus 1. Great. Now I found the inverse of this. Go back to the green and let me write the rule. Where is my green? Here is my green. So x of t equal. I'm going to plug in here the 2 outside for both of them. The 2 outside, all of those, e to the 2t minus 1 minus e to the t minus 1 times u of t minus 1 minus e to the 2t minus e to the t. Now I found the x of t. Great. Don't forget that you are going to solve the system, the blue, the white one here in the black. We found x. How to find y? Can anyone help? How to find y? I found the x.
we will get W2.
Yes, we will get W2. Then divide W2 by W to get Y capital. Then take inverse. You are right. Maybe one student will say, Professor, after finding x small of t in the next slide, we found x small of t. You can plug in xt here, or maybe x here. Plug it here. Or plug in it here, no problem for me. Let me plug in here x of t. Unfortunately, now my x contains the unit step function. And we didn't study how to differentiate the unit step function. You can find the derivative of the unit step function by Googled it. You can find it in Google, no problem at all. But we didn't study, so I prefer not to search for it. And I advise you to do like Selma said. I'm going to find W2 by replacing the second column by my right-hand side. Then divide W2 by W to get Y capital. Take inverse Laplace to find Y small. And that's enough. Okay? So let me write here in the coming slide only the steps. I'm not going to do that in details. I'm sorry because I don't have time to do that. But it's very easy for you, I think. We can do that, by the way, because we have a black slide here. But let me write here because I need to solve more problems. And if I have time, I can go back here. So here, the step now, let me use which color? I'm not sure which color should I use now. Yeah, so I found it. So I'm going to use the red to find W2. Now I'm going to find W2. Don't forget the W2 is what I'm going to leave the first column. So it is s minus 4 and negative 3, s minus 4 and negative 3. and I'm going to replace it by the column of the right-hand side. So 2e to the negative s, 2e to the negative s divided s, and e to the negative s divided s, divided by s. You will find this number. I'm not going to do that, okay? So after that, you will say, so here you will do that. You will say that your y capital, it is given to be W2 over W. Okay, you will get an answer. You will take yt equal inverse of the answer of y capital. If I have time, so I will go back now. If I don't have time, please try to do it by yourself, okay? Any question before I start solving the third problem today? No questions, let me start. This system. Notice now your system of second order. And by the way, you can also solve system of integral differential equations. Not only differential equation, but also if you have integral equations, system of integral equations, you can solve it using Laplace transform. Because as I told you yesterday, from yesterday lectures, in your exam, you will find one problem from yesterday lecture. Absolutely. Similar to today lecture. Similar to tomorrow lecture. All those lectures are very important. Now let us together try to solve the system using Laplace transform. For me, I remember if I need to solve any system using Laplace transform, system of differential equations, system of integral equations, I need to apply Laplace transform for all terms of my equations. Let me start by the first equation and take Laplace transform for all terms. So here the solution. Here the solution. First step, Laplace transform of all terms. So I have Laplace transform of second derivative of x plus Laplace transform of x small minus Laplace transform of y small is given to be 0. Don't forget your initial conditions. I memorized the rule. It is given to be s squared x capital minus s x of 0 minus x prime of 0 plus Laplace of x small, it is x capital, minus Laplace of y small, it is y capital equal 0. Now, x small of 0 is 0 cancel out. The derivative here is negative 2. The initial condition at negative 2 and negative plus, move it here, so it will be plus. It will be minus, I'm sorry. And I'm going to take x common factor from here. So x common factor, I have s squared plus 1 minus y. As I told you, I'm going to move this, it is negative and negative plus. Move it here, so negative 2. This is my first equation. It is an algebraic equation. Now let me do Laplace transform for all terms of my second equation. So here I have second step, Laplace of y double prime or double dot plus Laplace of only y small minus Laplace of x small equal 0. The rules, I remember it is s squared y capital minus s y small of 0 minus y prime of 0 plus Laplace of y small, it is y capital. I'm sorry. It is y capital minus Laplace of x small, it is x capital equal 0. Let me simplify my equation now. Here 0, here 0, here negative 1, move it here, it is plus 1, and let me write the x first. So I have negative x. The y, I can take x common, y common factor, so I have s squared plus y, plus 1y, this is my y, equal, as we agreed, it is 1. It's 1. This is my second equation. Notice I always try to write x, notice x below x, y below y, okay? Now for me, by the way, you are free, you can use the substitution, multiplication of anyone by a specific amount, add them together. From equation number 1, I can find y and plug in 2. So you are free. I'm not sure. For me, let me use the grammar rule because I need you to practice how to use it. Okay? So I'm going to find W. Let me use the blue now, maybe, or the red, no problem for me at all. So the W, Roneskin determinant equal S squared plus 1 minus 1 minus 1 S squared plus 1 equal this by this. So it is S squared plus 1 S squared plus 1 minus minus, so it is a plus. Minus minus, it is a plus, and minus from my mind, so it is negative 1. So equal, multiply please. It is S squared times S squared is given to be S to the power 4. I'm going to multiply this by both of them and the 1 by both of them. So you have 4 terms. Plus S, so it is S to the power 4 plus S squared plus S squared plus 1 minus 1. So equal S to the power 4 plus 2S squared. I can take S squared common factor, so I have S squared plus 2. This is my W. Let me find W1. W1. I agreed with you that to find W1, replace the first column by your right-hand side. My right-hand side, it is negative 2 and 1. And here, negative 1 S squared plus 1 is given this by this, which is negative 2 S squared negative 2. Negative this by this, so it is a plus 2. I'm not sure if I did any mistake here.
Plus 1, I think.
Plus 1?
Yes, negative 1 times 1, negative 1 minus plus 1.
I don't understand, Sam.
Doctor, it's negative 1 times 1. You made it plus 2.
Yeah, you are right. Negative 1 times 1, it's negative 1. And I have negative, so it's negative plus 1. Great. So equal negative 2S squared minus 1. This is my W1. I know that after finding W1, I can write my first unknown, which is X, equal W1 divided W, which is given to be negative 2S squared minus 1 divided by S squared bracket S squared plus 2. So I can say that I can write now the following. Notice that will give me my X small of t. It is the inverse Laplace of this fraction. It isn't easy fraction. How to find its inverse Laplace? How to find the inverse Laplace of this fraction? What do you think? How to find inverse of this?
I think we can split it.
Split it into 2 fractions. You are right. So Laplace inverse of the first one, which is negative 2 S squared divided by S squared plus 2 minus Laplace inverse of 1 over S squared plus 2. Now, in the coming slide, I'm going to find inverse of each one of those. I can cancel out this with this. Am I right? So in the coming slide, X of t, or let me find one of that one by one, then I will go back to my answer. So using the green, Laplace inverse, you need me to find Laplace inverse of 1 over S squared plus 2. What do you think about Laplace inverse of this? What do you think? Do you have a rule similar to this?
Yes, the
We
sine.
have sine.
Yes. Sine what?
Sine root 2.
But you need root 2.
Yes.
Am I right? So I'm going to write here root 2 and here divide by root 2. Okay? So now I can write the following: 1 over root 2 sine of root 2t. I found the first one. The second one, it was 1 over, yes, 1 over s squared plus 2. So you need to find 1 over s squared plus 2. How to find inverse Laplace of this fraction, please?
We can use partial fractions.
Yes, you are right. You are right. Second method, please.
We'll split it to two things, 1 over s squared times 1 over
Great. Great. So I can write this fraction as a product between two fractions, 1 over s squared times 1 over s squared plus 2. All right, by this writing. Now I can deal with this product as f capital and g capital. So here, this is my f capital, and this is my g capital. I remember the rule, I must write f small convolution g small. Where is your f small, please? Where is your f small?
it's t.
It's t, the inverse of this. Where is the inverse of this? 1 over s squared plus 2. Where can I find the inverse of this?
We got it in the previous step.
Yes, we find it here. This is my g small. This is my g small. So let me apply the rule using the green. So equal the t convolution 1 over root 2 sine root 2t. The convolution is given by the formula of the integration. So I'm going to write here the integral. By the way, 1 over root 2 is a constant, so take it out of your integral. No need to write it. So 1 over root 2 integral from 0 to t. First function tau, second function sine root 2 t minus tau d tau. Do you remember how to integrate a product between two functions? One of them is the exponential and the second, sorry, one of them is the trigonometric and the second is polynomial. Do you remember?
By parts.
By parts. This tau is my u, so my du, it's d tau. And this sign with d tau, it is my dv. So my v is what? What is your v? Integral of sine is negative sine, but you have here not minus. So let me repeat. Integral of sine, it is negative cosine. And here you have negative, so it is a plus. And you need to divide by the coefficient. So v equal 1 over root 2 cosine root 2 t minus tau. Okay, let me apply the rule here. So equal, I'm going back to green, equal 1 over root 2 bracket, the rule for the integration by parts, which is u times v minus integral video. So my u, it is tau, times my v, which is 1 over root 2 cosine or root 2 of t minus tau. Don't forget your boundaries from 0 to t, minus the integral of v, which is 1 over root 2 cosine. I can write 1 over root outside of the integral, no problem. Cosine root 2 t minus tau, all of them times du, which is d tau. Don't forget the boundaries of your integral. Now also I can find this integral easily. Let me plug in first. So 1 over root 2. Now the time for t. So here t, 1 over root 2. Cosine t minus t, cosine 0, which is 1. Okay, minus. The time for 0, 0 times anything, it's 0. Minus this integral. This integral is very easy for me. First of all, I have 1 over root this as a constant. Integral of cosine, it is sine. But here you have minus, so you have here plus. And you need to divide by the coefficient, so 1 over root 2 sine root 2 t minus tau. Don't forget from 0 to t is given to b. So 1 over root 2 bracket t over root 2 plus 1 over 2 bracket. Plug in first t, plug in first t. So t minus t 0, sine 0 is 0, minus. Plug in 0, so sine only t. So equal, leave root 2 out, leave root 2 out. So I can write it, I'm sorry to write it here. 1 over root 2, t over root 2 minus half sine t. Half sine t. So this is the inverse of the second one. Now you need to go back to your x. Let me check in yellow. Let me write in yellow my xt. 1 minute. So xt equal. Sorry. No, just 1 minute. Give me 1 minute. We are here. We are here. Am I right? This xt. So here xt, go back to this. So it's negative 2 of the first. So negative 2, here the yellow. It's negative 2 of the first answer, which is 1 over root 2 sine or root 2t. The second one, it's negative. All of those. 1 over root 2 bracket t over root 2 minus half sine. Here I forget the root here. It has here root. So root 2t, root 2t, root 2t. Okay? This it is sine. I found the x. I didn't found the y. Now, if you take this x, notice your x contains sine and contains only t, sine and t. I think if you go back here to equation number 2 in this equation, notice what I mean now, this equation. Plug in your x which you found here and no, not this equation, I'm sorry. I need the equation number 1. Go to equation number 1 here. You have the x and you can differentiate it twice. It's very easy for you because you know the differentiation of x and t, sorry, for t and sine. So you can easily find the y. Or find w2, then divide w2 by w to get the y capital, take inverse Laplace. Now I advise you to plug in this equation. It's easier for you because the differentiation is easy. But for the previous problem, you need to differentiate the unit step function. Unfortunately, differentiation of the unit step function isn't easy. You can find it on Google, but I don't ask you to do that. Okay?
دكتور
Yes.
can we solve a problem لما نحط الايكويشن يعني نحط value of x في الايكويشن يعني can we solve it مرة عشان نشوف بس عاملة
Now,
ازاي؟
yes, I can do that. Actually, I did. So your question now, after finding x of t, yes, can I plug in here the x and here to get the y? This is your question. Okay, Abdurrahman?
Yes, دكتور.
Yeah. We did for the first equation, but first problem which we did today, but it was very easy. Let us now do that for our equation. Please take print screen for this screen now, or I'll take because I need this equation. So I'm going back. I'm going to black slide now. I'm going to black slide here. I can do that here. I can do that here. I'm going to use maybe the white. The first equation, it was x double derivative, am I right? X double derivative plus x
minus 1.
equal y.
Yes.
Am I right? Equal y. Now you need to find the second derivative. Let us find here first derivative. X dot equal. a derivative of sine, it is cosine, and you need to multiply by the derivative inside, so you cancel out root 2. So negative 2 cosine root 2t minus 1 over root 2 bracket. The derivative of t over root 2, it's only 1 over root 2 minus half derivative of sine, it's cosine, and you need to multiply by the root. So negative root 2 over 2 cosine root 2t. This is the first derivative. Now second derivative equal. A derivative of cosine, it's negative, and I have root, so I have 2 root 2 sine root 2t minus 1 over root 2 bracket. Derivative of this is 0. Derivative of cosine, it is negative, so it is a plus. You need to multiply by root 2 times root 2, it's 2, divided 2, it's 1, so you have only sine root 2t. Okay? Is it clear how to differentiate your x? Now let us plug in here. Instead of x double prime, you have 2 root 2 sine root 2t minus 1 over root 2. So, by the way, here, if you multiply this 1 over root 2 by, yes, sine, only sine root 2t, okay, plus all those are x double dot. Plus, you need to add x. Where is your x? All those. I'm going to write them here. Okay, equal my y. That's enough. You can cancel out some terms. No need to do that for me. If you arrive to this step in the exam, you will take full mark. Is it clear now, Abdurrahman?
Yes, doctor. Thank you, doctor.
Yeah. Now, also, maybe if you need to practice more, please try to find W2 by replacing the second column of the non-scale determinant by the right-hand side of your differential equations. Sorry, right-hand side of your algebraic system. Then divide W2 by W to get Y capital, take inverse to get the final answer. Okay? Now, I'm not sure if I have time. Actually, I have extra one problem. Yes, we have. I have this problem. So what do you think? Do you want me to start solving this or go back to this one, which we didn't find the W2? Do you want me to start solving this or finding W2 in the previous one? Is it difficult for you to find W2?
No, I don't think.
So do you prefer to start solving this? Anyone of you speak, don't worry.
And either is fine.
I don't understand, David. Repeat.
يعني I don't mind.
Yes,
No,
other students. I need. What do you think, Sami?
We can start solving this problem.
Yes, doctor, let's do it.
Yes, Muhammad. What do you need me to do? إجبالي.
Yes.
So to solve this one?
Yes, doctor.
Okay. So let us here take the Laplace transform for all terms of both of my equations. So here, let me start here the solution. First step is to take Laplace transform for all terms of your equation. So Laplace of x prime or x dot equal to Laplace of y plus Laplace of e to the t. Laplace of x dot, I know it is s x capital minus x small of 0 equal to y capital plus Laplace of e to the t, it is given to be 1 over s minus 1. Now, I'm going to move y capital here and x0, which is 1 to the right-hand side. So I have s x capital minus 2y capital equal 1 over s minus 1. As we said, it is minus, so it will be plus 1. I can leave this one, or I can make them have the same denominator. Don't worry about this step, okay? Now, so this is my first equation. This is my first equation. Second equation, so second step, take Laplace and Laplace for your second equation. It is y dot equal 8 Laplace of x small minus Laplace of t. That will give me sy capital minus y small of 0 equal 8x capital. Am I right here? Minus Laplace of t, it is 1 over s squared. Now I'm going to move y0 here to be 1 and move 8x. So I have negative 8x plus sy equal negative 1 over s squared plus 1. This is my second equation. How to solve this system now? The system of algebraic equations. Two unknowns, x capital and y capital. Who will help me now?
We can use grammar.
Use grammar rule, okay? Grammar rule. Let me use the red also to find the w. So w is given to be s negative 2 negative 8s. So it is s squared minus 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 minus. Okay, 3 minus is give me minus 16. So it is s minus 4 and s plus 4. W1. I'm going to replace my first column by the right hand side. So it is 1 over s minus 1 plus 1 and negative 2 and negative 1 over s squared plus 1 and s equal. Product, please. So it is s over s minus 1 plus s plus 2 plus 2. Am I right? Because minus and minus 2 over s squared. Am I right here?
Yes.
Now, you can leave it like this. You are free, by the way. This is W1. Now, after finding W1, could you please tell me what should I do? I will write my x capital equal W1 over W, which is given to be S over S minus 1 plus S plus 2 minus 2 over S squared, all divided by this product, S minus 4, S plus 4. What should I do now? So split your fraction into 4 fractions. So I'm going to write here Laplace inverse of x capital equal Laplace inverse of each fraction alone, s divided s minus 1 all divided by s minus 4 s plus 4 plus Laplace inverse of s divided by s minus 4 s plus 4 plus 2 Laplace inverse 1 over s minus 4 s plus 4, okay, minus Laplace inverse of 2 over s squared all over s minus 4 s plus 4. Now I'm not going to find all of them. Let me choose one and start finding its inverse. Please choose one which you need me to find its inverse. Which one do you prefer me to find its inverse now? What do you think?
You can take the last one.
Last one. So let me do the last one. But give me 1 minute. because I don't have black slide here. 1 minute. Repeat, Salma.
I said يعني if you don't have another slide we can use it on the margin اللي هو in this part.
Actually, because I finished, so I'm going to do the last one, okay? So last one, it is 2 over s squared. So it is 2 over s squared. Let me use maybe the blue now. So we need to find Laplace inverse of 2 over s squared, 2 over s squared, all divided by, sorry, s minus 4 and s plus 4. S minus 4 and s plus 4. This fraction can be written as the following. Laplace inverse of 2 over s squared, s minus 4, s plus 4. Am I right here? What do you think? Yeah. Now look for me, how can I find it? You will find it using partial fraction. You will get full mark. Now for me, I'm going to do the following. It is Laplace inverse of 2 divided s squared, or let me, yes, just give me 1 minute. 1 minute. I need to write the following. 1 over s squared times 1 over s squared minus 16. Can I do that? Because those two terms are s squared minus 16. Now this is my f capital, come from my f small, which is only t. This is my g capital. Can anyone of you give me the g small?
I think it's shine.
Shine what?
Shine 4t over 4.
Over 4, you are right, so you need 1 over 4 here. The rule said find the convolution between f and g. So equal the convolution between t and 1 over 4 shine 4t, which is given to be 1 over 4 outside, integral from 0 to t, tau shine 4 of t minus tau d tau. How to integrate this product now? Do you remember? This one is your u, and this one it is your dv. And you will write u times v minus integral v du. I'm not going to do it because I think all of you can do that. But notice, if anyone of you now, while he tried to study or she tried to study, didn't do this integration by parts, so they will find it's very difficult in the exam. So for me, because I don't have exam, so I'm not going to do. But you, because you have an exam, you have to practice now to do it in details, okay? Now, actually I finished. I'm not going to continue solving the rest fractions because I think this one is the most difficult one. The first one, I think it's very easy to use partial fraction. Okay. And by the way, this also partial fraction, and this also this is a rule, by the way. And this also, it's by the way, it is s over s squared minus 16, so it's cosine. You can do that. So it's very easy, I think. So now, do you have any question? Any question? So we can meet at 1 o'clock if you have difficulties to do the worksheet. Please start preparing for the final. Yes, Muhammad.
Do we have any new material? Are there any new lectures tomorrow or after tomorrow?
Yes, actually tomorrow it's a new idea. No relation about what we studied and tomorrow lecture at all. It's depend on the power series. And this from tomorrow lecture, you have 1 question in your final about 10 marks. Okay, but after tomorrow, only practicing and solve some problems about tomorrow lecture. So only tomorrow we have new ideas, not new rules, maybe new ideas. Because I think all of you studied the power series in calculus 3. We need to use those power series and the properties of them to solve differential equations. But after that, no new materials at all.
Alhamdulillah.
I know that, yani, because this semester is very fast, so the students find it's difficult to collect all the materials. But you have to. And by the way, in the previous summer, a lot of students get high marks. So don't worry, you can study.
I hope so. Yeah, thank you.
You're welcome, Hamid. Other students, do you have any comment or any question? So we can meet at, welcome all of you. We can meet at 1 o'clock if you have any difficulties. So welcome. Bye bye all of you. Goodbye all of you.